Okay, so we're going to look at multiplying complex numbers today. So the first example that I'm going to look at is if z is equal to 4 plus I, find iz. Okay, so I need to basically find I multiplied by z. So I have I bracket my 4 plus I. Right, so I times 4 will give me 4i. I times I will give me plus I squared. Okay. Right, I know that I squared is equal to minus 1, so basically this is going to become 4i minus 1, and we always put the real first, so it's minus 1 plus 4i is my final answer. It's really important that you always put the complex number in the form a plus bi. Okay, so that's how we always write complex numbers, so my real number had to be at the front. Okay, so we've looked at different types of transformations already, but basically multiplication of a complex number by I is the equivalent of rotating the complex number anti-clockwise through 90 degrees about the origin, and then multiplication by minus I is the equivalent of rotating the complex numbers clockwise through 90 degrees about the origin. So I'm going to explain what I mean by that because I'm going to complete the question dealing with it now. Okay, so the question here, z is equal to 2 plus I. I'm asked to find z2 if z2 is equal to I, z1. Right, so what I have to do now is I'm going to multiply this part I. So z2 is equal to I times z1, which is 2 plus I. Okay, so I times 2 gives me 2i. I times I will give me plus I squared. We know that I squared is minus 1, so that's equal to minus 1 plus 2i. That's what z2 is equal to. Then I'm asked to plot z1 and z2 on an Argand diagram. So that's what I'm going to do now. Okay, so here I have my Argand diagram. The first one I need to plot is my 2 plus I. So I start at the origin, go over to 2, up to I, which is going to be here. So this is z1. My next one is minus 1 plus 2i. So I start over here, minus 1 plus 2i. So this is z2 plotted. The final part then, girls, it asks me to describe the transformation that maps z1 onto z2. So I can see here that z1 is mapped onto z2 by anti-clockwise rotation. Okay, so this is my origin. Right, and then multiplication by I rotates the complex number anti-clockwise through 90 degrees. So basically, I don't have it drawn on graph paper, but if I was to do it here, I would have my right angle is basically what's happening. So that's anti-clockwise if I'm multiplying by a complex number, so just I. Okay, the next example is example 8.16, and here I'm given different complex numbers, so z1, z2, z3, z4. The first question asks me to find z1, z2. So basically now this means here that I'm multiplying z1 times z2. So z1 is 2 minus 7i, and z2 is 3 plus 7i. Okay, so it's the exact same rules as algebra. So I split my bracket, so I take the first term from my first bracket multiplied by everything in the second bracket, 3 plus 7i. I take my second term from my first bracket, minus 7i, times everything in my second bracket, 3 plus 7i. 2 times 3 will give me 6. 2 times 7i will give me plus 14i. Minus 7i times 3 will give me minus 21i. Minus by minus will give me minus. 7 times 7 will give me 49. I by I will give me I squared. Alright, so what I have here, so 6 plus 14i minus 21i minus, right, so that's minus 49. We know that I squared is minus 1, so I'm going to fill in minus 1 there. Right, now I have 6. So plus 14i minus 21i will give me minus 7i. And minus by minus will give me plus 49. And then just tidying up, so I have 6 plus 49, and that's going to give me 55 minus 7i. And that's my answer for Z1, Z2. I'm going to go on now and do the next one, which is to find Z3, Z4. So Z3, Z4. So this here means that they're being multiplied by one another. So Z3 in this case is a half minus 3 over 2i bracket z4 is 4 plus 6i. So the exact same procedure as before. You take the first term from your first bracket, a half, times everything in your second bracket, 4 plus 6i. You take your second term, which is minus 3 over 2i, times everything in your second bracket, 4 plus 6i. Okay, so I have a half times 4 will give me 2, and then I have a half times 6i will give me plus 3i. Then I go on here, and I have minus 3 over 2i times 4, that will give me minus 6i. And then I have minus 3 over 2i times plus 6i, that minus by plus will give me minus 9i squared. So then I have 2 plus 3i minus 6i minus 9i squared is minus 1. So I have 3i take away 6i is minus 3i, minus by minus gives me plus 9. So my final answer is 11 minus 3i. The next example is I have to evaluate square root 5 minus 3i times square root 5 plus 3i. Okay, so I have two brackets, follow the same procedure. I take the first term, which is root 5, times everything in my second bracket, root 5 plus 3i. Take my second term, which is minus 3i, times everything in my second bracket, root 5 plus 3i. So then root 5 times root 5 will just give me 5, and then 5 times 3i will give me plus 3 root 5i, minus 3i times root 5 will give me minus 3 root 5i, minus by minus, or minus by plus will give me minus 9i squared, plus 3 root 5i minus 3 root 5i, they're cancelled, so I'm going to have 5 minus 9i squared is minus 1, so it's going to give me 5 minus by minus will give me plus 9, and my answer then is 14. Okay, so here I have two brackets that need to be multiplied again. So I take my first term, which is root 2, times everything in my second bracket, so root 2 minus root 3i, and then I take my second term, which is plus root 3i, times everything in my second bracket, root 2 minus root 3i. So root 2 times root 2 will give me 2, root 2 times minus root 3i will give me minus root 6i, plus root 3i times root 2 will give me plus root 6i, and then I have plus root 3i times minus root 3i will give me minus 3i squared. Then what I need to do is I need to tidy it up. So minus and plus root 6i will cancel, so I'll have 2 minus 3i squared is minus 1, so I'll fill in for that. So I'll have 2 minus by minus will give me plus 3, so my answer then is going to be 5. Okay, so this is example 8.18. So I have Z1 is this and Z2 is this. I'm asked to find the modulus of Z1 and the modulus of Z2. So I know my modulus formula is equal to A squared plus B squared. So my modulus of Z1 is equal to the square root of 3 to be squared plus 4 to be squared. So 3 to be squared is 9, 4 to be squared is 16. That's equal to square root of 25, and my answer then is just 5. The next one then I need to find the modulus of Z2, so Z2 is equal to 5 to be squared, plus I have my 12 to be squared. So the modulus of Z2 is equal to 25 plus 144. So the modulus of Z2 is equal to the square root of 169. Modulus of Z2 then is just 13. Okay, so the next one then I have to evaluate z1, z2, so I'm multiplying them by each other. So z1 is 3 plus 4i, z2 is 5 plus 12. Right, I have to separate my brackets, so it's the first term times everything in my second bracket, plus my second term, which is plus 4i, times everything in my second bracket, 5 plus 12i. 3 times 5 will give me 15. And 3 times 12 will give me plus 36i. 4i times 5 will give me plus 20i. And then 4i times 12i will give me plus 48i squared. Then what I have to do is I have to tidy up a little bit. So 15, 36 plus 20 will give me plus 56i. Plus 48, we know that I squared is minus 1, so just filling in here. So I have 15 plus 56i, plus by minus will give me minus 48. And then fully tidying up, I have minus 33 plus 56i. So that's z1, z2. That's what that's equal to. Part that asks me z1, 2, and we know we've just found out that z1, z2 is minus 33 plus 56i, and my modulus formula z is equal to the square root of a to be squared plus b to be squared. So then I have here, it's going to be minus 33 to be squared plus 56 to be squared, and then minus 33 to be squared is 1089, and 56 to be squared is 3136, and when I add them together I get the square root of 4225. So then my modulus of z1, z2 is equal to 65. Part 4 then asks me how are the modulus z1, z2 and z1, z2 related. So we've just figured out that z1, z2 is 65. We know that the modulus of z1 from a previous question is 5, and we know that the modulus from z2 from a previous question is 13. So I get 65. So therefore they're the same answer. So they're equal, and that's how they are related.